Hi, I'm Brad with Remote Energy, and welcome to this presentation on PV module MC connectors and grounding. You can see in that photo there on this slide that that is an MC connector. MC is a particular brand, but the idea is that this is a connector that will connect solar modules to other solar modules, and there's a positive and negative there. And it's very important to understand how to construct this in the field because almost every system that we build and make in the field, we will need to extend these wires and install one of these connectors on the ends of those wires. Our main objectives today in this short presentation is to differentiate a little bit between the different types of solar module junction boxes and the different types of connectors that are used on those that are available in the market today. And then at the end, we're going to talk a little bit about grounding of PV module frames and the mounting rails upon which the PV modules get attached when they're mounting on a roof. Let's start here and take a look at the module junction boxes. You can see two photos on the left side of this slide. The upper one is a factory wired junction box. In other words, the module comes with the junction box and the interconnection wires already connected inside that junction box. So what you see in this photo is what you get when you purchase this type of module. It comes with the connectors already on the ends of the wire, and they are labeled positive and negative. The photo on the bottom is a little bit close. It's a close-up of a smaller junction box. Often on the smaller boxes, they do not come with the wires installed from the factory. You would install those in the field. These would be smaller modules in the 60 watt or lower range, and you have to add in your wires as part of the installation. That'll be your job rather than the job of the factory. And so you have to be able to do that in such a way that it doesn't pull out when people are, or there's tension on that cable. So you can see that a connector has been added to the end of the wire. That's the yellow part in this photo. And that has been crimped onto the wire. And that connector has a ring terminal or a fork terminal on the end of it that slides under that screw and gets tightened down. So that you do in the field, you have to identify very carefully which of those screw terminals is the positive terminal and which is the negative terminal. And then you notice on the bottom of that junction box there's some strain relief connectors that the wires go through as they enter that box. And so after you put the wire into the box, you tighten that strain relief connector and it seals up the wire with kind of a rubber gasket inside of there so that no water can enter that junction box. So generally those connectors come with the junction box, and it's your job to get the wire and put a connector on it and make the connection inside the junction box. The photo on the top, the wire and those strain relief connectors are already done and made from the factory. Oftentimes with many of the newer modules, the larger 60 cell, 72 cell modules, there is no way to access that junction box and do any work in there. It's already sealed from the factory, whereas the one on the bottom, you can open that junction box and make those connections in there as well. On the right side of this slide, you can see that there's various brands that we are showing you of intermodule connectors that are on the market. The most widely used one in the market in North America is the MC4 connector. It's a brand. The company is MC Multi-Contact, it's called, and they make connectors for a lot of modules. But other module manufacturers have used other brands like Amphenol connectors you see in the upper left. There's another brand called a Tyco connector, very similar in appearance, all of these. The MC3 connector was an earlier version made by Multi-Contact, and the difference between it and the MC4 is that the MC4 has a locking mechanism. When you insert it, it locks in place, and you need a tool in order to undo it. That's true of the Amphenol and the Tyco connectors shown in this photo as well. The MC3 connector is no longer suitable to meet the National Electric Code for countries operating under that code. you need some type of a connector that requires a tool to open it up. And the reason that is so that kids can't come along and pull on it, or people that don't know what they're doing and then they pull on it and you've made a long series string and all of a sudden it's open, it's at 300, 400 volts or something, and so it can be very dangerous. So the code said that we need to have those to be locked and you need a tool to open them up. So they're just some of the brands that are on the market. They are not necessarily compatible with each other. So whatever brand the solar panel that you're purchasing has as its connector, you need to purchase those brand connectors to build your extensions from the array down to the next component. So you will have to make those in the field with the same brand connector in order that they serve well. On this slide, we are looking at a particular brand, an MC multi-contact, the 4th generation connector. So it's called an MC4. And you can see on the left side that there's really 4 parts, 2 parts to make the positive connection and 2 parts to make the negative. The metal parts you see there, one is male and female, and one slides into the other and makes the actual electrical connection. And then the plastic part around it, is to protect so you can't touch those live wires after that connection's been made. And so this slide is showing the tools needed to use. You need a specific crimping tool to make this crimp. It needs to be made very well. It needs to last 25 years of the installation. And I can also mention here that many of the fires that have started on PV systems have been shown to be the result of poorly installed and poorly made connections on these MC4 connectors or other brands of connectors on the site. They're made poorly and there's loose connection in there, and that looseness causes arcing where the electrons are trying to jump across the gap, and that's a very hot situation and can start fires. So it's very important that technicians learn how to make this type of connection in the field and do it correctly. So there's 4 parts, 2 parts for each side, 2 for the positive, a metal part and a negative, and a metal part and a plastic part, and then 2 parts for the negative side, the metal part and the plastic part as well. So you can see in the photo here, they've stripped the wire a little bit, put it in the very end of that. That's maybe a 1/4 inch long or 4 or 6 millimeters of stripped wire there. Then that's set inside the crimping tool and squeezed, and you can see in the bottom right photo that it's curved around and made a very solid connection for that wire, and you can pull on that connector and it will not come off of that wire. It's been well connected and that connection will last a long time. So once you've made that crimped on the metal part, you push both the wire and the connector into the plastic part of the connector, and it snaps in place. And you can see on the bottom left photo there that that metal part now is recessed down inside the plastic connector, and so you can't get your finger or your tongue there. So this is a safe, no-touch type connector. So it's very difficult for people to actually touch that, even if it was open and a live wire inside of there with voltage present. It'd be very difficult to get your finger in there to actually make that touch. That's one of the reasons they made these in this way, to make it safe. On the right side here, with that blue tool that comes with the whichever brand connector you're using, you buy a tool from them like this. And in this case, they're using that tool to tighten up that strain relief connector on the bottom of that connector so that it squeezes around the insulation of the wire with a rubber grommet inside of there, and that prevents any water from entering the connector. Notice that that connector says do not disconnect under load. It's stamped right on the connector. In other words, stop the flow of electrons, stop the current flow before you disconnect this. Turn off the inverter, turn off the charge controller, turn off the breakers in the combiner box, or whatever means you have to stop that flow so that you can open those up safely. If you try to disconnect this while the system is operating and there's a high voltage, those electrons will try and jump across that gap as you begin to open up that connector, and that's a very dangerous situation. You have an arc of electricity in the air, which is a very high temperature, and it's dangerous for both the installer or the person working, as well as it's going to damage or burn those metal parts of the connector inside. So make sure you turn off power, check that there's no flow of current, and then disconnect this. This photo here is showing, or this series of photos is showing up on the top that you're about ready to plug the two parts. The positive one is on the right, the negative one is on the left, and you push them together. The metal part inside there makes the connection, and the plastic part on the outside clips into place like you see on the right side. It's fully seated, and those two little wings there catch, and now you can't pull it open just by your hands. And so again, we use that blue plastic tool that comes from the manufacturer, that particular connector, and that blue tool slides over there. It squeezes those two wings together so that you can open that up if you need to in the future. But it's very difficult in this way then for any person just to walk up and grab it and open it up. So it's a safety feature to need a tool to open up this connector. The final part of this presentation is just this one slide to begin talking about the fact that there's a metal frame around that solar module, and that metal frame, if something goes wrong, has the ability to carry or conduct electricity. And so if something does go wrong, if one of the positive wires, for example, insulation gets rubbed through, and now the copper inside that is touching the frame of this module, when the sun comes out, that current could start flowing around the frame of the module. And so we want to do what we call equipment grounding of all module frames and the racking. And so there's many different ways to do that. This provides an emergency path for that electricity to go, and we can set up our inverters or our charge controllers to advise us that there is a ground fault on the system. There's various methods and ways to do this, but a few key things we wanted to point out here in this first time we've touched on equipment grounding. Notice on the bottom left we have two photos of very similar looking connectors, but one on the left is tin plated copper, and that's touching against the aluminum frame of the module to make that connection. But what you don't see in this picture is behind that connector there's a stainless steel washer between that connector and the module frame, and that stainless steel washer has some little teeth that bite into the aluminum frame of the solar panel. And that way, when you have those little teeth that can bite into the frame, it gets past that coating of anodization that they put on the top of the aluminum frame. That's to protect it from corroding, but we need, as electricians, we need to make an electrical connection with the actual metal. So we need to get past that layer of anodization. So the one on the bottom left then is going to last many years. The one on the bottom, the left side, but the right-hand photo, that was someone that used an indoor rated connector. In other words, it's not really copper in there. It's some kind of steel or metal or zinc or something. And you can see the screw is not a stainless steel screw and began to rust out very quickly. So this is not going to last and serve us for the 25 years we need. So you need to buy equipment that is rated to be outside in the moisture, in the rain, in the weather, and not deteriorate, not corrode. So generally speaking, we use copper and stainless steel when we're making the connection between the module frame and the connector, the grounding lug. It should be made with a stainless steel screw. That way we don't have any corrosion or galvanic interaction between two different types of metal. Normally if we put some kind of steel or galvanized zinc or something on the aluminum frame, those two over time are going to kind of react with each other and start to eat each other up. This does not happen using stainless steel hardware with those aluminum frames. So you can see in the upper left-hand photo, there's 4 modules there come together on a racking. This is the back side of it. And so they're actually connecting the frames of all four of those modules together with a ground wire using stainless steel hardware and tin-plated copper lugs. On the right-hand side of this, many of the manufacturers of the racking system have now started manufacturing parts that serve to make that grounding connection between the module frame and whatever railing or racking system you're using. These are often called weebs. They're washers for electrical something bond, I can't remember. But the point is that it usually has some kind of little teeth or some kind of thing to bite into the frame of the module as well as bite into the frame of the rail, so that when you tighten that with a stainless steel bolt, it makes an electrical bond between the frame of the module and the metal railing. So now you can have all the module frames and the railings all tied together, and then you take a wire down from one spot on the railing system to the ground. On the bottom there, you can see it's trying to show that this is a clamp that would slide between two modules and hold them down onto the racking system. And so it's trying to show you that below that little dot there, there's a little tooth sticking out that would bite into the frame of the module. In that far right photo there, this is a case of a stainless steel washer that goes down between the racking and the module frame, and when that bolt is tightened, you can see that with that arrow, when the bolt is tightened down, those little nubs sticking out of that stainless steel washer will bite into both the frame of the module and the racking, and so those two are bonded electrically, or so they're tied together. So if current's flowing on one of them, it'll flow on all of it, or the same voltage will be present on all of them if there's some problem. We will discuss grounding a lot more in future lessons, but we wanted you aware that when you're thinking of module and its physical characteristics, one of the things that we're going to have to do is make sure that metal part of the frame is attached to the earth. So thank you for joining us for this presentation today. I hope we'll see you again soon.